All right. Now, chapter 5 is kind of a short chapter. All right. So that's kind of good. I don't honestly. I don't think we're going to have um, the test. I think probably next Thursday. All right. It'll be Thursday. All right. Yes, you can use that one right there. Just take it over. Thank you. All right. Now, last week we did, or last Friday I said, we did the in-center and we did the circumcenter. Now listen, again, just a brief review. Circumcenter are the perpendicular bisectors. All right, because they are perpendicular bisectors, they are equidistant from the sides. All right, and the perpendicular bisectors means that that point of concurrency, which just means where all three lines intersect, is equidistant from the vertices. All right, so the perpendicular bisectors are called the circumcenter. All right, which means that they are equidistant from the vertices. The angle bisector was equidistant from the sides of the triangle, so that created what was referred to as an in-center, which means you can inscribe a circle, all right, or it is equidistant from the sides of the triangle, all right. Now, today, really all we're looking at is the median and the altitudes, all right. One of them is called the centroid, and the other one is called the orthocenter. Now, the orthocenter is not really that much exciting about the orthocenter, but the median, sometimes referred to as the middle of the triangle, it's not really the middle of the triangle, but basically what they're saying is that's the kind of like the center of mass, which basically means if you cut the triangle, believe it or not, it would balance perfectly on that point. All right. So again, the median. All right. If you want to highlight this, the median, where the three medians intersect, is called the centroid. All right. Now, if you'll notice here, this is a median because RA is congruent to RB. Then BS is congruent to SC, and AK is congruent to KC. So if you were to draw all three medians, they would intersect at a single point. All right. Now, what is interesting about that is that it divides that median into proportional parts. So what I mean by that is UK could be called X, UB would be called 2X, and then we would say that BK is considered, guess what? 3X. That's all. All right. Now, I did not say that they're all equal. They're not all equal unless it's an equilateral triangle. So I would have to say, for example, if US is Y, then AU would be 2Y. Is everybody with me? Just give me 1 second. I'll promise you. And then I could say this is Z, and that would be 2Z. All right, again, guys, I'm just telling you, it's really simple. And even on the test, I used to tell kids, the way they draw it accurately. So even if you forget, you could make a good educated guess. All right, it's really simple. Really, really simple. All right, so that's what they're trying to tell you. All right, so If they give you the whole length, you just divide it by 3. And that gives you the distance from the centroid to the base. From the centroid to the vertex, you multiply by 2. Everybody hear me on that? Again, like I said, these to me now, it starts getting a little bit easier because it's just rules and knowing the rules. All right, that's all you have to do. It's really that simple. Yes, sir. You can do whatever you need to do. Take care of business. All right? So let's go down here to the exercises real quick. All right? So, CF is 18. All right, so in my opinion, all right off the bat, I always try to tell kids, just fill out everything that you know and then answer the question. If CF is 18, then UF would be what? 6. And UC would be what? 12. It's that simple. If UB is 12, then EU would be what? 6. That's how easy. And AU is 16, so UD should be what?
8.
Guys, I'm telling you, that's all there is to this lesson.
Why?
Yes, sir.
Why is it always going to add up to 3?
Because it's not that it adds up to 3x, it's that's the proportion.
And it's always going to get longer and longer 2 times.
That's exactly what the rule is. That's what the rule is. All right? Yes, sir.
Why is CF, like, CU is 12, but UF is 6? Like, I understand that 12 plus 6 is 18, but why is it not 7 and, like...
The same proportion is for all of them, don't you agree?
Okay.
You with me?
Why 12, 6?
Because, remember what I was trying to tell you up here? I was trying to tell you up here, watch. The pink, or purple, whatever you want to call it, is 3x. Do you agree with that?
Right.
So if I want to find this part, I would take whatever that value is and divide it by 3. You with me?
Okay, so you have to take the sort apart.
Yeah. I mean, you could take BU and say that's 2/3 of x, or 2/3 of the whole length is what I'm trying to say.
Yeah, you could divide 18 by, or take 2/3 of 18
Yeah,
by 12.
that's right. That's right. Lots of ways. Just to me, it's easier just to divide by 3 and then double it. But you can do that. Quick.
How do you know you use 8?
How do I know that? Because isn't AU 16? Isn't that what it says? Does that answer your question? Because you divide by 2. It's half. Right?
You just have to look at it to know which side is like the 2/3 side.
No, I mean, yes, you could do it that way, but the rule is, here is the centroid.
Oh, it's the vertex.
Yeah. The distance from the centroid to the vertex is twice as big as from the vertex. I mean, as from the centroid to the side of the triangle. All right? So now you can just answer those questions. UD is what? 8. Well, I don't even care. Well, let's put them in just to make sure. EU would be what? CU would be 12. AD is 24. UF 6. BE is 18. Does everybody agree with that? Nothing to it. I agree. Absolutely nothing to it. Just a rule. All right? So here we go. All right. Now, UK is 12. So right off the bat, CU would be what? 24. That's how my recommendation is. All right. Then it says that EM is 21. So if EM is 21, what do we know? EU is how much? 7, right? That's it. It's how easy. 7 and what? 14. And I'm assuming UD is 9, so that means UL is what?
UJ is 4.
Oh, yes, that's what I said. UJ, thank you. 4.5. UJ is 4.5. Everybody agreeing with that? Everybody see, it's very simple. Very, very simple. All right. Now let's fill it in. So we say CU is what? 24. MU is 7. CK is 36. JU is. EU is.
14.
Thank you. And JD? 13.5. All right. That was everything you need to know about the centroid. And to find the centroid, it is the medians. All right? It is the median. All right? And what is exactly a median? A median is from the line from from one vertex to the opposite side. And what does it do to the opposite side? Cuts it in half. Is it perpendicular?
No.
No, it doesn't have to be perpendicular. If it was an equilateral triangle, then it would be perpendicular. Yes.
So does the median create to
No. You see how all sides are different. Do you agree? You with me? So again, that's a good thought. And it would if it was an isosceles triangle or if it was equilateral triangle. But those are just the rare exceptions. Okay? So let's go to the next one. All right. Now, here we have what's referred to as an altitude of a triangle is the segment from the vertex to the line containing the opposite side, all right, at a right angle. And again, the altitudes are called what? The orthocenter. Now, ortho, you'll hear that in math. Ortho just means perpendicular. That's how we kind of knew that it was the heights or the altitudes, because that's the one that has to be perpendicular. All right, that's the one that has to be perpendicular. All right. Now, the next one, it's asking us to actually find the coordinates of the orthocenter. And over here, somebody, they found the line and then they drew the intersection. And what is that intersection point?
7-6.
Is it 7-6?
Yeah.
All right. So,
Yeah, it
is it?
is. Yeah, 7-6. Because the axis has the y-axis and it's
Yeah. All right. So, I'm trying to. What's nice about notability for this is for us, because we're using notability, it can be kind of easy to find that point. All right. So let me try to show you what I mean. I want to find the coordinates of the orthocenter. I want to find the coordinates of the orthocenter. So let's add some graph paper. I think there was. That's what I was trying to review. But I don't want to worry about that right now. I just want to show you. All right, so here we go. All right, so let me go ahead and do this so we can figure it out. All right, so I'm going to find the orthocenter. All right, so 1, 0. And then 6, 0.
and then 3, 6. Now let's try to draw that line for that triangle. Alright, so there's our triangle. Now, for me personally, I just feel like the first one I would draw would be this one because it's just the easiest one. Does everybody see how that's the altitude?
Mm-hmm.
Does everybody agree with that?
That middle line.
Yeah. You see it's perpendicular to the side? Do you agree? And so that equation, if you wanted to, would just be, let's review that. The green equation is just x equals 3. Does everybody agree with that?
Yeah.
Stay with me now. All this is good review. All right, so now all I have to do is I have to find the perpendicular line through one of the other points. All right, so what I'm going to do is this. I'm just going to, actually I'm going to change colors, right? So I'm going to draw the perpendicular. Obviously that's not perpendicular. And then, wow, that maybe look like it's perpendicular right there. Everybody see that? So this red is perpendicular. Do you agree? Now, I'm not sure if it's perpendicular, correct? I just kind of eyeballed it. So how do I know if it's perpendicular? So let's figure out the slope of this. So the slope of that, I went down 2 and over 1, right? So slope is -2. Do you agree with that, guys? Yes? Hello? The slope is -2. Now look, here's what I'm saying, guys. It's just not that hard to get better. Starting now. Right? You just got to listen to what I'm saying, though. The slope of this line is -2. So what would be the slope of the perpendicular?
2.
No, think for yourself. 1/2. Slope of the perpendicular would be 1/2. Everybody agree with that? So I'm going from, don't forget, this point down here. Is everybody with me? Right? So I would go from that point, what?
Up 1.
Up 1 and over 2. I would go up 1 and over 2. So, just so you can see it, all right, I want to go from this point up 1 and over 2. Up 1 and over 2. And guess what? That was in fact the what? That was the line. Is everybody with me? So the orthocenter would just be what? 1, 2, 3, 1. Anybody else say that? 3, 1 is considered the orthocenter. The orthocenter. Right. And we'll do another one just to make sure you're good. Because I do think that's kind of tricky for some kids. All right, yes, sir.
So you don't have to, why don't we have to do all 3?
Well, you can, but listen, I know they always meet at one point. Do you agree?
I would say that.
So I really only need 2. But if you wanted to check your work, right, then you could do it. All right. But let's go ahead and print out the next one. All right. Let's go ahead and double check that. All right, here we go. Let's do 1, 0. One, 0, and 4, 7. And then 8, -3. All right, now let's draw. Now this one's a lot more annoying, I think, right? And the reason we say it's a lot more annoying is because I don't see a vertical or horizontal. Does everybody agree?
Mm-hmm.
So again, it's just a matter of, again, look how simple. Very, very simple. All right? So what I want to do is, I want to find the slope of that line. What's the slope of that line? One, two, three, four, five. Negative 5 halves. Or 1, 2, 3, 4, 5, 6, 7, 9, 10. Yes, I got negative 5 halves for that. Now again, I'm just trying to tell some of you guys, this doesn't do any good just to write down negative 5 halves just because I said negative 5 halves. You're supposed to look at that and say, yeah, okay, it's negative 5 halves. Because all he did was he went down 5 and to the right 2. That's what I'm asking. Does anybody have any question why I got negative 5 halves?
Yeah.
So, from this point right here, I went down what? And uh-oh. Yes, hold on, I went down 4. So I went down 5 and over 2.
Why would you put it that way?
Because it entered.
Point.
Yeah, exactly. Thank you, some of you guys. But let's say you didn't know that. We would just go what? Down what? 10 and over 4.
Why would you do that?
It's the same thing. 10/5 is the same as 5, or 10/4 is the same as 5 halves.
I don't understand why it's 5 halves and it's not 4 halves or it's not 6 halves. Like why'd you go down? My question is like why did you go down 5 and to the right?
What did you want me to go down?
I'm just asking why you did that over down 2 to the right 2, down 3 to the right 2, down 4.
Because, okay, that's a good question. So now watch. The reason I didn't do that is because if I go down 2, I don't know how much over that is.
Oh, because it's not. Oh, because it's none of them's on the line.
Right. Welcome. Okay? So now, what I need for you on that is now that we have that information, all right, what I want to do now is I want to find, come on, I want to find the slope of the perpendicular. The slope of the perpendicular would just be what? So I write down slope of the perpendicular is 2/5. Now, here's where kids have trouble. I don't know why, but I'm trying to draw the perpendicular to this line. From what point? From the vertex that doesn't contain, that's not on that line. So I'm going from there. So from there I'm going what? I'm going up to and over 5. So up to 1, 2, 3, 4, 5. And I'm now going to draw the altitude in. That's the altitude. Anybody have any issues with that? What?
So when you're like first starting off, it doesn't matter which point you choose.
Well, I mean, it doesn't matter what side you choose. You got to choose one of the 3 sides.
But it doesn't matter.
It doesn't matter which one. So now, because you asked me that question, which one do you want to do? You want to do on the one on the left, or you want to do the one on the bottom? All right, so let's look at the one on the bottom. So now what I'm trying to do is I'm trying to find the slope of this line. All right, so Ashton, why don't you tell me the slope of that line since you weren't sure of the other one? Slope is equal to what?
Okay, the slope is down to.
Down to 1, 2, 3, 4, 5 would put it right there, according to my calculation. If I go down 2
Well, there's nowhere else it's closer to.
and over 5,
Oh, so you can do the point one.
yes, there you go.
I just thought that was.
So it would be what?
1, 2. So down 3 to the right 1.
Yes. Is everybody happy with that now? So did he say the slope was -3/7? Everybody else see that? Go ahead.
On the orange line, the slope of the other one. Okay. So you got the perpendicular slope from the other thing. But that's 5,2, not 2 o'clock. The point you plotted on the triangle.
Yeah, I'm not. Now listen to me. This is somewhat of a coincidence. If you're relating that to this, just a coincidence.
Oh.
Nothing to do with it. All right. So now my question is: does everybody understand that the slope of the bottom line is -3/7? So then all you have to do is you have to tell me the slope of the perpendicular would be what? 7/3. Now the question is, where do I go 7/3? From what point? The one on the very top, right? Now, how do I know it's the one from the very top? Because look, guys, because this right here is the slope, or that's the line we're going to. So it has to be coming from this vertex up here. Does everybody agree with that? So I have to go, should I go up 7 and to the right 3?
No.
No, that wouldn't make sense because you're going away from the triangle. So I'd have to go what?
Down 7.
And left 3. Down 7 and to the left 3. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Wow. That's kind of weird. I didn't realize that. Those two lines are perpendicular. That's exactly right. So the orthocenter, listen, this is an unusual one. The orthocenter can actually be on the triangle. All right? You're right, it's not the center of mass. So
why do we do the first thing?
well, if I was smart, if I could have just recognized the fact that that's a right triangle, I wouldn't have had to do anything. Right? If it's a right triangle, it's the intersection of the two legs. I don't know what you mean.
Like, why did we have to do it?
Go ahead. What? Like if I was looking at this clearly, I would have just said this is a right triangle. So this, the orthocenter, yes. The orthocenter in this particular case is 1, 0. The orthocenter is 1, 0.
The orthocenter is what exactly?
It's where the three altitudes intersect.
And the altitudes are
The altitudes are the line.
Yes. So, right, it's perpendicular to the opposite side.
Oh.
Right, so from this point right here, from this vertex, I have to draw the altitude to this line. And it's just this one. Right? So that right there is a right angle. Right? So if I'm going from now, if I'm telling you I'm going from this vertex here, it's just this line. That's perpendicular.
What is the orange line called?
This right here, the one I'm going right here. Is that the one I'm talking? Is that the one you're asking?
Yeah. Is that
Yeah, that's just the altitude.
just the altitude?
Right. So again, let me make sure I'm clear. That is the altitude. It's called the altitude or the height because from the vertex, it is perpendicular to the opposite side.
Okay. So the orthocenter.
The orthocenter is where all three of those lines intersect.
Perfect. And then
Just like this centroid right here, this is called the centroid
so we're all
because those three lines, those three medians intersect at that point.
how's the circumcenter?
The circumcenter is where the three perpendicular bisectors intersect.
Okay.
The incenter is where the three angle bisectors intersect.
There's human centers.
If you try to point out a specific altitude to a person, why not? how would you point out that altitude? Would you be like altitude of length or speed?
I'm not sure what are you trying?
There are 3 altitudes, right?
Right.
So then how do you point it? How do you, is there a name for each altitude?
No.
Okay, so just-
No, the 3 altitudes intersect at the orthocenter.
Why is it called the orchestra?
Perpendicular.
So,
Whoa, is that because they make the teeth straight?
Perfect. Perpendicular to your gums. What?
What's the formula?
I don't really think there's a formula for this.
Perpendicular slope minus the.
No, there isn't one for this.
so 1, 0 is what we're trying to find.
Yes, 1, 0.
Not 1.
Yes, the orthocenter. Yes, that is the answer. 1, 0.
And that's supposed to be the center of mass.
No, I did not say that.
That's the
Centroid. Yes.
Oh.
All right. So
But normally it's not going to be on the.
unless it's a
Right triangle.
right
where
triangle,
is it on?
it can also
If we know the right triangle, I can just say that.
yes. It also remember the orthocenter. This is a rare one. It can be outside of the center if it is an obtuse triangle. Yeah.
Right.
All right.
So many sense.
Yeah, that's why it's to try to remember all the rules. Kind of silly.
I get real math
All right.
again.
This is wrong.
So here we go.
You
R
like
big
it.
mass.
All right. Yes, your assignment is knock out the next 2 pages.
Oh,
What?
All right.
Should people like go from?
You're welcome.
Wait, but I still don't know what it would normally look like. What would a normal orthocenter look